talk about radicals and rational exponents. Okay?
I remember rational.
Okay? All right? Okay. We're talking about radicals and rational exponents. Okay? Radicals. Okay? When you see that word radicals in math, okay? In math, it means you have some sort of root. It might be a square root, it might be a cube root, or a fourth root, or a fifth root. Do you guys know about those? Okay, we're going to learn about them today. And when we see the word rational, rational begins with this word ratio. What does ratio mean? Comparing two numbers. What's one way you can write a ratio?
7 over 14.
7 over 14.
Or 7, these two dots.
Or the two dots. Or just 7, 2.
Yeah.
Okay? Right? And so I really want you to think about that first way that you said, 7 over 14, the fraction. Because when we see rational exponents, we're going to be thinking about fractional exponents. I'm not sure.
Rascals.
Oh, little rascals. Totally unrelated. All right. Okay. All right. Okay. So, all right. For this, what does the square root of x mean? Okay. Now you should know how to do square roots. Okay. Like for example, what is the square root of 4? Is 2. What is the square root of 9? What is the square root of 16? Square root of 25. Square root of 36. Square root of 49. Square root of 64. Square root of 81. We're going to stop here. Square root of 100. 10. We could keep on going with this all day, right? Okay? So when you think about a square root, we're asking ourselves what number times itself equals 4, right? So when we do the square root of 4, we're thinking what number times itself equals 4. And so the answer is 2 because 2 times 2 is 4. And when we do the square root of 25, we're thinking what number times itself gives us 25. And so 5 times 5 gives you 25. 5 is the answer. Now I could ask, what's the square root of 17? Right? The square root of 17, what number times itself equals 17? There's no whole number answer to that, right? We would have to use the calculator. The calculator will give us a big long decimal for that. But whenever we are looking at a square root, that means what number, let me write these down, these are notes. What number times itself equals x. And x could be any number. It could be 4, it could be 9, it could be 16, it could be 17, it could be 28. Now, we call this a square root. We do not write it, but it has an invisible little 2 sitting out here. It is a square root. We don't write that 2 right there, but it has a little invisible 2. Kind of like whenever we write just an x, we don't write it, but it has a little invisible 1 right there. Or it has a coefficient of 1. Right, so when you have a square root sign, we don't write this 2 out here, but it's called a square root. Something that is squared is raised to the second power, so a square root would have a little 2 right there. So a cube root means what number times itself three times equals x. So, for example, if I want the cube root of 125, okay, that would equal 5. And it equals 5 because 5 times 5 times 5, or 5 to the third power, gives us 125. Okay, so if the cube root of x is what number times itself 3 times equals x, hey Zeus, what do you think the fourth root of x is going to be? Okay, give it to me. Tell me what to write down. What does it mean? Oh, I forgot. You did not bring your glasses today. Cole, what should it be? Yeah, what does the fourth root of x mean? What would we say that means? Good. So what number times itself 4 times equals x? So, for example, if I ask for the fourth root of I have to pull out my calculator for this one. You could do fourth. Let's do that one. 4 through 16. You could do that one. What's the 4 through 16, Adam? Okay, it would be 2 because 2 times 2 times 2 times 2, that'd be 4 times 4, which would give us 16. All right. So the fourth root of 16 would be 2. And so any type of root that you have, any type of radical that you have, is if we have the nth root of x, so this could be any number right here. It could be 1, it could be 2, it could be 7, it could be 14. That means what number times itself 5 times equals x. Not 5 times, n times. N times. What number times itself? N times. It's not working well this morning. Yeah, this is really n times. I'm just being lazy and not writing out times. So what number times itself? N times. I should write it out though. N times. So you can have a 6th root, 7th root, 8th root, a 1000th root. You can have a 1.8 root. You're not going to see that, but you could. So you can have all these different roots. Yes. The n matches whatever number is in front of the root. So, like the n could be any. It could be a 5th root, 6th root, 7th root, a 1000th root. There. So, the n is what type of root it is, and that tells you how many times you're multiplying the number. The x is whatever number's on the inside, so that's like the answer that you're trying to get. All right. Okay, now, many of you were using your calculators today on Delta Math. Whenever we take a quiz on this Wednesday, we are not going to be allowed to use a calculator on it. They gave a few numbers that were a little bit bigger, but no, it will have harder questions. Also, it'll have some questions like Delta Math, but it will have some that are harder. I'm not sure. I haven't finished making it yet. Most of these I have to do multiple choice if I do it on Canvas because you can't type them in. But I may just do paper one. I haven't decided yet. Okay. Can't take a square root of negative. No number times itself will give you a negative. Right? So negative 4 times negative 4 gives you positive 16. Right. Whenever you get to upper level maths, you will learn about the I. But for right now, we don't need that. Everything we do pretty much is real numbers. Everything we do in Math 1 is going to be real numbers. There are imaginary numbers, and you will begin those. You do them a little bit in Math 2, I think. You might not do them until Math 3, depending. Okay. All right. Okay. So we are doing 1 through 6, and we're going to do them without a calculator. Okay.
8.
So the first one. Hold on. Give us a chance to think about it. Not everybody's worked ahead. All right. So the first one will be 8 because 8 times 8 gives you 64. All right. Okay, Gabe. The second one, the cube root of 8. It would be 2 because 2 times 2 times 2 is going to equal 8. So 2 to the third power equals 8. So the cube root of 8 is 2. Because this asks me what number times itself 3 times is going to give me 8. Now, if it was the square root of 8, we don't know the square root of 8, right? Without a calculator. But the cube root of 8 is 2. Okay? Aiden, what about number 3, the fourth root of 81? All right, we're doing the opposite. We want to know what number times itself 4 times would give us 81. Now, sometimes when you get to these bigger numbers, guys, quiet. Okay? Sometimes when you get to these bigger numbers, you probably don't know them off of the top of your head, right? But what number would you guess might be 81 if you multiplied it 4 times? Okay? If you try 4, 4 times 4 times 4 times 4. 4 times 4 is 16. This 4 times 4 would also be 16. 16 times 16 would be 6 times 6 is 36. I know right now it's not right. But I'm going to continue. That'd be 3, 6, 7, 8, 9, 0, 1, 6, 6, 256. All right, this is too big, right? So you want to try a smaller number. Okay. If you try 3, 3 times 3 times 3 times 3, that would be 9 times 9, and 9 times 9 is 81, so 3 is the correct answer for number 3. Okay. Julie says number 4 is 15. Okay. All right, so if I test this, because we are not using a calculator on these, 15 times 15, 5 times 5 is 25. Carrier 2, 5, 6, 7. 225, that is correct. 15 is correct. Okay. All right, Evan tells me the next one is 4. So 4 times 4 times 4. Oh, just 3 times. That would be 16 times 4. And 16 times 4, that's 24. Carry your 2, 4, 5, 6. Hold on. Hold on. What am I doing? I'm losing my mind. Alright, let me go back. It's not 40, this is 4. So, 24, carry 2, 64. Okay. I could, but I was writing it out. I was just getting mixed up. Okay, so we get 4 for that one. And this one might be wrong. Change that. This is a typo on the worksheet right here. Change this to a 32. It's a typo on the worksheet. Okay. Alright, this is not a very big number to be to the 5th power, right? So 2 is probably where you want to start. Plus it's divisible by 2. So 2 times 2 is 4. That'd be 4. That'd give you 16 times 2, which is 32. So 2 is your answer here. Okay? Alright. Any type of root is also called a radical. So we talked about that already a little bit, but that word radical in math refers to any type of square root or cube root or 4th root or 5th root. Okay? So, radical expressions, this is what we're really needing to get to, can also be written as rational. Okay? Rational or fractional exponents. Okay? So, one of the main reasons I want you to be able to do this is because typing the 5th root of 32 on the calculator is not very easy to do. You have to go to a bunch of different menus and find stuff that's hard to do. But we can write radical expressions with rational exponents. Let me show you what it looks like. If you have the b root of x to the a power, okay, you can write it like this: x to the a over b. Okay? Now, I think what helps me remember this is this right here. Whatever number you have out here, that is your root. Where do roots go on a tree? The bottom. So they go on the bottom of the fraction over here, right? So that number out here is the root. It goes on the bottom. Whatever exponent you have inside goes on the top. You can also do this the other way. Whenever you have x to the a over b, you can write it. The bottom of the fraction is your root. It goes out here. Then you'll have x to whatever power you have on the inside. Okay. So at times we might need to take our rational exponents and write them as radicals. Sometimes we need to go from radical to rational. Okay, so let's just practice. I thought I had some easier ones. I thought, but I did. What happened? Okay. All right, hold on. We're not packing up yet. I'm gonna give you a couple extra bonus problems here. All right. Cube root of x to the 4th. Okay. Let's see, Ian, how could we write that? Cube root of x to the 4th. The x to what power? Okay. This number right here, it's your root. It goes on the bottom of the fraction. The inside goes on the top. X to the 4 over 3. Okay. What about if I had the square root of x to the 9th. Ooh, this one doesn't have a number out here. You do not put a 1. You put a 2 because it is a square root. So, Tristan, how can I write that one? X to what power? Nope. 9 over 2. Roots go on the bottom of a tree. Okay? What about the 5th root of x to the 5th? Okay, Connor, what would I get? X to what power? Not quite. We don't do anything to this exponent right here. We just leave it like it is. So 5 over 5. What is x? What is 5 over 5? So that would just be x for that one. X to the first power. Okay? We're going to practice with this some more tomorrow. That worksheet that I gave you is homework. If you have not finished it, you need to finish it. Okay? The whole thing, front and back.